Good afternoon, students. Today we are going to discuss about differentiability. Before I go for what is differentiability and what is the relationship between continuity and differentiability, let me first discuss what is differentiation. We all know that every function has its graph. Now suppose this is the graph of a function y equal to f of x, and say this is a point, say A in the domain. Now if A is this, then we know this is A f of A, right? And suppose then this is the point which is say B. So we know this is B f of B, right? Now if I name this point as capital A and this as B, then we know that AB is the second line for the curve. It cuts the curve at two distinct points and the AB is the second line. Now suppose this B is little larger than A, which is A plus H. So then I have this point as A plus H and f of A plus H, right? So A changes from A to A plus H. That H is a very small change in A. So if H tends to 0, that is, this point B starts moving towards A, and then you know the second line AB tends to become tangent to the curve, and the slope of this tangent will be y2 minus y1 f of A plus H minus f of A upon A plus H minus A. y2 minus y1 upon x2 minus x1 is the slope of a line, and when limit h tends to 0, and we call that as the derivative of a function at A f dash of A. When h tends to 0, the tangent line tends to become, the second line tends to become tangent to the curve, and therefore we have the slope of the tangent as the derivative. Therefore, when you work on tangents and normals or slope of a tangent, you would be differentiating the function, because a derivative is nothing but the rate of change in y with respect to x we call as dy by dx. Also, it is slope of a tangent, that is the derivative of a function. Now, to differentiate, we would be using this definition, and this we call as the differentiation by first principle. If you remember, we have done this earlier. If a function is continuous, then it's not necessary that it is differentiable always. Suppose I have the function y equal to modulus of x. Now we all know that this is a continuous function because modulus of x graph you all know. If I find the critical point, that is the value of x when the polynomial becomes 0, that is 0, x is 0. So if I find the left-hand derivative that is on the left of 0. So I have limit h tends to 0 from left, f of x plus h minus f of x upon h. That was the definition which I discussed just now. Now, when it is, this is f of x is modulus of x. So we all know f of x plus h is going to be modulus of x plus h, right? Now it tends to 0 from left, right? That is, if it is on left of 0, that means it is less than 0. So you will have limit h tends to 0. This would be minus h, right, upon h, and that's minus 1 because it's on left of 0. If I work on the right hand derivative, limit h tends to 0 from right, again same definition, f of x plus h minus f of x upon h. So if I go on the right of 0, this becomes h by h, and that's 1. Left hand derivative is not equal to right hand derivative. Therefore, it is not differentiable. That is, though this is a continuous function, it's not differentiable. That means we conclude one thing, that it's not necessary that the function would be differentiable if it is continuous. But yes, if it is differentiable, then it must be continuous function. That also we are going to discuss slowly in one by one classes. So today what we understand is, if it is continuous, it need not be differentiable. To be differentiable means left hand derivative should be equal to right hand derivative. What is differentiation? Differentiation is rate of change in one quantity with respect to other quantity. Differentiation is also slope of a tangent. Now, rate of change in one quantity with respect to other quantity, you have done a lot of it in physics, right? Your acceleration and velocity and all, right? ds by dt and so on. So, they are all rate of change in one quantity with respect to the other. So, when we discuss dy by dx, that is rate of change in y with respect to x. Thank you.